Wow, welcome back from the break. This is still Physics Meal under Science Tutorial, and it is still the special edition, which is the revision series for preparing students that are going to write the WASI and NECO SSC. So far, we have looked at temperature and its measurement, and we want to involve ourselves in one or two calculations before we look at other aspects of temperature and its measurement. So far, we have been able to look at the meaning of temperature, different temperature scales. Then we considered the fixed points, and we looked at the relationship between the different temperature scales, also using the fixed points. We talked about the concept of fundamental interval, and we also looked at types of thermometers, and then we looked at liquid in glass thermometer, resistance thermometer, and constant gas volume thermometer. We're able to generate some expressions because we say that the thermometric substances, that their properties change with change in temperature. And we saw that in liquid in glass thermometer, the length of the liquid column changes with temperature change. And we saw that resistance of a wire changes with temperature change, and then the pressure of a gas also change as temperature changes. So we were able to obtain various expressions, and those expressions will help us to carry out some calculations now. So let's write down few expressions that we are going to use uh, for calculations. Let's put them down. Let's put them down quickly so that we can move. So let's remind ourselves some of these expressions. We're able to say that uh, Fahrenheit is actually 1.8 C plus what? 32. You remember that. We also say that K is what? 273 plus that. Then we generated other expressions where we say that LO theta minus LO naught all upon LO 100 minus LO naught is equal to theta over 100. We also say that R theta minus R naught all upon R 100 minus R naught will give us theta over 100 also. And then we say that P theta minus P naught all upon P 100 minus P naught is equal to theta over 100. So we generated these few expressions, and we want to use them for calculations. Yeah, as far as temperature is concerned. So let's pick some examples. So we say worked examples. These questions, the questions we are going to solve are questions adapted from WAEC and NECO and so on and so forth, JAMB and the rest of them, because this is a revision series. So we'll go this way. All right, let's look at it. Let's look at the first question here. You can say the upper fixed point of a thermometer marked in millimeters is 180 millimeters, while the lower fixed point is 30 millimeters. Now, they say calculate the temperature. Calculate the temperature in degree Celsius when the thermometer reads 45 millimeters. All right. Okay. We have equation. Now we say that anytime we want to solve problem in physics, it's usually good for us to apply the principle of IC. IC. We have talked about this principle before. Say IC. IC. It's only those that can see that can actually solve problems in physics. What's the principle of IC? I means identify, S means set up, E means explore, and the last E is execute. Now, whenever you want to solve problem, you must identify the, the quantities given, that's the variables given, and also identify the unknown. Then as you're identifying those parameters, you also set them up. You know, virtually all the parameters we use in physics, they have symbol. So when you identify them, set them up using their symbol. If you identify a particular parameter and the symbol of that parameter is K, represent it with K. If the symbol is R or X or T, represent it with that symbol. So representing those identified parameters using the appropriate symbol is what we call setting up, that's the X. Then after setting up all the parameters, we'll now begin to explore, to search for appropriate expression that will help us in the calculation. And then once you get that expression, then you execute, yes. You actually execute. You substitute the values and then carry out your calculation. So they say the upper fixed point of a thermometer marked in millimeters. So this thermometer, instead of in degrees Celsius, it was marked in millimeter to measure the length of the liquid column. So they say that the upper fixed point is actually 180 millimeter. In other words, what we are trying to, if we use a diagram in sort of, and we have this, the upper fixed point now, 180 millimeter, that corresponds to 100 degrees. The 180 millimeter is the length at upper fixed point. The length at upper fixed point, that's what it is. Then they say that the lower fixed point is 30 millimeter. What corresponds to that is 0 degrees. They now say at 45 will be somewhere in between here because we are moving up. So at 45 millimeter, what is the what? Temperature. So all these they have a symbol. So let's take the question and bring out and set it up properly. The upper fixed point of a thermometer marked in millimeter is this. Now that's the length at 100 is what? 180 millimeter. Okay? Why the lower fixed point is that? So the length at 0 is 30 millimeter. They say calculate the temperature. So we are looking for theta. That's the temperature. We don't know. Calculate the temperature in degrees when the thermometer reads a length. So the length at that temperature, theta, is 45 millimeter. Okay, now you look at this. So we have set this up using appropriate symbol, similar to what we have just done here, only that we use the symbols here. Okay, now we have to explore. Let's search for appropriate expression. It's not difficult to search because we don't have much expression here. That's the man. That's the man. That's the man that we are going to use to find the missing man, theta. Oh yes, I just entered my compound. I was told that theta is missing. I saw theta here. I saw theta here, but the people that will enable me find theta, they are all available in this particular equation. That's why I have to use that equation. So L theta minus that. So I'm using L theta minus L naught all upon what? L 100 minus L naught equals theta over 100. Beautiful. So we now substitute. That's what you have to do. What is L theta? L theta is 45 minus 30, that's L naught, all upon 180 minus 30 equals theta over what? Over 100. So if we continue, physics have ended. From here to here is physics. Everything here now is mathematics, yes. You see, that's what makes mathematics very beautiful. It's applicable everywhere. even those that do English, they also do mathematics. Because when they ask you to write essay, they tell you number of words you are going to write, and you start calculating. That's mathematics. So it's everywhere. Mathematics is universal. So we have this 45 minus this will give us what, 15. All upon 180 minus this will give us 150. So I have theta over 100. I can reduce this to its lowest term before clearing the fraction, because 15 is a factor of 150 and also a factor of this term. So when 15 divide 15 is 1, and when 15 divide 150 we have 10 equals theta over 100. So if we clear this fraction now, we are going to have 10 theta is equal to what? 100. 10 theta is equal to 100. So making theta the subject of formula, I divide both sides by 10, so I will have 100 over 10. So theta becomes what? 10 degrees Celsius. All right, that's it. Very beautiful. Very beautiful. So your ability to write out the parameters given is very, very important if you are going to actually solve the problem. So let's just go to another question without taking much of our time, because there is need for us to solve a lot of questions and also give you some questions that you need to take away and solve on your own. Okay, if you are ready, let's go to the second question now. Let's go to the second question now. Let's look at the second question. All right. Let's say that to a platinum resistor, a platinum resistance thermometer has a resistance of 4 ohms at 0 degrees and 10 ohms at 100 degrees. Now, assuming resistance is proportional to temperature changes, assuming resistance is proportional to temperature changes, calculate the resistance of the thermometer. Calculate the resistance of the thermometer when the temperature is 45 degrees. Oh, beautiful. Very beautiful. Okay, let's go. Now this is the case of resistance thermometer, platinum resistance thermometer. We know we talked about resistance thermometer, constant gas volume thermometer, and we also mentioned liquid in glass thermometer. The first example was actually a case of liquid in glass thermometer because we are considering the length of the liquid column. Here we are now considering resistance of what? Of a wire. Okay. The principle of IC, so that we'll see together. Let's go. A platinum resistant thermometer has a resistance of 4 ohm at what? 0 degrees. That's at ice point or at lower fuse point. So the resistance at ice point is what? 4 ohms. And 10 ohm at 100. So the resistance at 100 is 10 ohms. They say, assuming that resistance is proportional to temperature changes, based on what we treated before previously. We say that the principle here is that a change in the what resistance will bring about a change in temperature will bring about a change in what in resistance. So increase in resistance is as a result of increase in what temperature, and when temperature decreases, resistance will also decrease. So that's this assumption. Calculate the resistance of the thermometer. Calculate the resistance of the thermometer at a temperature theta of what? degrees. Okay? So assuming that they say calculate the resistance. So we are looking for this resistance. Resistance at a given temperature. That temperature is 45 degrees. Okay? If we come back here, we just see the mark that is available, and that's this mark. So we use that. R theta minus R naught all upon R 100 minus R naught will give us theta over 100. So we substitute. Quickly, let's substitute. What is R theta? That's the man I am looking for. Minus R naught is actually what? 4 all upon what is R 110 minus R naught, which is what? 4, is equal to 45 over what? Over 100. Okay? Mathematics now begins. So I can write this as R theta minus 4 all upon 6 is equal to, we can break this down. I know that 5 can divide 9, 5 can divide 20. So I have 9 over 20. Yes, 9 over 20. So we can now clear the fraction. So I'll have 20 bracket R theta minus 4 is equal to 6 times 9. When this multiply this, you remember your cross multiplication, or you just multiply both sides by the LCM of the denominators. That's how we actually clear fractions. So if you open this bracket, we have 20 R theta. Physics have ended with was 80. 6 times this will give us what? 54. Yeah, that's what we are going to have. 6 times 9 is going to give us what? 54. So we have 20 R theta is equal to 54 plus what? 80. That will give us 134. 20 R theta. So R theta now will give us 134 over what? 20. So when you divide that, that will be 13.4, because this 0 will take this there. 13.4 divided by 2. And when 2 divides anyway 13, we are going to have 6 remaining 1. Dividing 14 will give us that. So 6.7 ohms. That's what I'm going to have. So far, so good. We're going to take one more question, then I will give you the questions that you are going to solve as take away questions, so that we will know whether you actually followed what we have done so far. Because it's not all about teaching and teaching. We need to evaluate you also, and you need to evaluate yourself. It's also important that you go to the past questions, search for as many questions as possible as it concerns temperature and its measurement. Try to solve all the questions. Yes, try to solve all of them, because you don't even know where they are going to set your exams from. So you need to explore every opportunity. You need to go to different places to get questions, so that you'll be well prepared to face any question that they may throw at you in the course of the exam. Yes. We want you to have A1 in physics, we want you to have B2 in physics, we want you to have B3 in physics. We want you to have excellent results in sciences. Yes. All right. Let's take one more question, and then we now have to take our takeaway questions. Beautiful, beautiful, beautiful. Physics has been beautiful all this while. All this while, physics has been beautiful. Very beautiful. All right. Let's look at this. Let's say question number 3, the ice point. Okay, the ice and steam points. The ice and steam points of a mercury in glass thermometer of centigrade scale and of respectively to 3 cm and 19 cm of the mercury trade. What will be the temperature when the length is 12 C? Still similar. Still similar. Okay? Now, the eyes and steam points of a mercury in glass thermometer of centigrade scale and of uniform bore correspond, respectively, but you need to also respect yourself. And the best way to respect yourself is to study your book. Because if you fail to study your book, you move into the exam hall, people will begin to insult you. Because you start giraffing from left to right, then people can now insult you. So, but anyway, what we have there is respectively. I was thinking is, I respect yourself. Okay? So, respectively to 3 cm and 19 cm of the mercury trade. What will be the temperature when the length is what? Is 12 cm. When the length is 12 cm. Okay? Still the same principle. The eyes and steam point. The eyes point and steam point talks about the lower fixed point and the what? Upper fixed point. So they say correspond to 3 cm and this. So in that order, it means the eyes point is for this, the steam point is for this. Or this is for the steam point and this is for the eyes point. So we can now say that the length for the eyes point, length for the eyes point is 3 cm. And the length for the steam point is 19, right, centimeter. And they say, what will be the temperature when the length at that temperature we want to calculate is 12 cm? Okay. Our business is still very simple. We know who to use. We have L theta minus L naught, all upon L 100 minus L naught equals theta over 100. If you substitute L theta is 12 minus what? 3, all upon 19 minus 3. That's what you have. It's equal to theta over what? 100. Okay? So if you subtract 12 minus this will give us 9. All upon 19 minus this is 16. It's equal to theta over what? 100. Okay? Let's clear the fraction. We have 16 theta when this multiplies it's equal to 9 times 100. So 16 theta is 900. So what will be theta? 900 over what? Over 16. That's what we are going to have. 900 over 16. Now, if you don't have a calculator, we can actually still write this as 9 times 100. And write this one as 9 times 100. And then we do our division in an easier way if there is no calculator. We can still move straight and use the long division method, having this 900 and this 900 over 16. So we can now say when 16 divide 90, when 16 divide 90, the closest number that 16 can divide here is actually 80. When 16 divide 80, we are going to have 5. Oh yes. And that will leave us with 10. When 16 divide 100, 6 times 16 is about 96. So when 16 divide 100, we're going to have 6 remaining 4. Cannot divide 40, so we put 2 points there. When you divide 40, it's going to be 2 remaining 8, right? 2 remaining 8. And when you now divide 80, we're going to have 5. So we have this 56.25. That's what we are going to have. If someone had decided to just do 9 times 100 all upon 16. We still have 4 here as 25. That's what we are going to have. And when 9 multiplies 25, when 9 multiply 20 is 180, and when 9 multiply 5, we are going to have 45. And when you add it there, you have 225, which 4 can divide. When 4 divide 22, we are going to have 5 remaining 2 into 25 will give us 6 remaining 1. Put point into 10 is 2, into 20 is 5. We still have this. But you have your calculator, but you also need to learn how to do these calculations without what? Calculator. Because there are some exams that you may want to write, they will not allow you to use what? A calculator. All right. I believe so far so good. So let's actually take some questions. These are the questions you are going to solve on your own. On your own. Please solve it, send it to me. Wherever you're watching from, just send it to my WhatsApp. The WhatsApp number is on our Facebook page. Send it to my email. You can also send it to Facebook Messenger through our Facebook page, Mathematics Meal or Science Tutorial. Any of the pages, just send it. Let me know whether you understood the class. And then if there are things that you still find difficult as far as temperature and its measurement are concerned, then you need to let us know. Our business is to make sure that you improve in the study of science. Okay. We need to, it's a meal, so we have to give you some meal that you will take away. At the end of the occasion, people usually they give people take away so that when you get home, people will know that you actually attended an occasion. So when you get home, people will know that you actually attended physics meal occasion. Just that's why I want to give you some takeaway questions. All right, let's look at this. All right. One, a resistance thermometer has a resistance of 20 ohms at 0 degrees and 85 ohms at 100 degrees. It says if this resistance is 52 ohms in a medium, calculate the corresponding temperature. Calculate the corresponding temperature. That's question 1. Okay. So the distance between the fixed points of a centigrade thermometer is 20 cm. What is the temperature when the mercury level is 45 cm above the lower mark? This should be 200 cm above the lower mark. Okay. And the third one was so that we the lower and upper fixed point marked on a mercury in glass thermometer are 210 millimeter apart. The end of the mercury coding in the tube is 49 millimeter above the lower fixed point in a room. What is the temperature of the room in Kelvin? What is the temperature of the room in Kelvin? Oh, beautiful. Very beautiful. So, just these three questions so that we know how far you have followed us on temperature and its measurement. All right, we shall continue with our revision, but we need to move to another topic. There is need for us to look at various topics, and that's why we have to touch as many topics as possible, because you know that we still have so many topics to touch. So if you still have any problem or you encounter the question that concerns temperature and its measurement and you are finding it difficult to solve such question, let us know. We will help you. Yes, that's our business, to help you out, so that when you enter the exam hall, you will not be seeking for help. Oh yes. So that's where we're going to draw the curtain for now. But remember, solve your takeaway question. Forward it to us so that we can know whether you really understood this particular topic in this revision series. Thank you and God bless you. Remember, we are not going to let you go. It's not possible until you are transformed. Physics transformation. If it did not take place in your life, we will not let you go. Thank you and God bless you.